Hi everyone. In this session, we will discuss about Turing machine construction, that is given a problem at hand, how you can construct a Turing machine in stepwise manner. In the previous session, we have dealt the theoretical components of the Turing machine. What is a Turing machine? What is the purpose of a Turing machine? And then what is a move, how a move in a Turing machine is represented, and how can you describe the Turing machine? That's instantaneous description of a Turing machine, and also the language accepted by a Turing machine we have seen. Okay. So in this session, we'll just go through construction of Turing machine. Let us take this example, the language 0 power n, 1 power n. Yes, which means, and the condition given is n is greater than or equal to 1. So how many number of zeros occur, that many number of 1 should be followed by the number of zeros. So since n is greater than or equal to 1, the simplest string will be 0, 1. If n is 2, it will be 2, 1. Sorry, 2, 0, 2, 1. If n is 3, it is 3, 0, 3, 1, and so on. So in a Turing machine, we know that we have a infinite tape. The tape length is infinite, and initially the tape symbols will be filled with a special symbol called as this blank. So all the cells will be having this special symbol called as blank, and we represent the blank using the uppercase B, or otherwise we have one more symbol called like a B with a slash. This can also be used to represent blank symbol, but we will, for simplicity, we can consider capital B as a blank symbol. Okay, and parallelly over here I have shown the transition table of a Turing machine. So inside this infinite tape, the tape symbols that I will be having is a blank by default, and then the input I am going to read is, it consists of zeros and ones. And what is this x and y is, whenever I read a 0, I am going to mark it as x, and whenever I read a 1, I am going to mark it as y. So therefore all these are the 5 symbols that will be in the infinite tape of the Turing machines. So I am placing this in a tabular form: 0, 1, x, y, and b. Okay, so the logic behind this solving this problem is that when you have two zeros and two 1, yes, I have two zeros and two 1. How I can solve this is, whenever I read, my tape head will be pointing to here. So whenever I read a 0, to make it clear that I have read that 0, I'm going to mark the 0 as x. Then for this 0 that I have read, I should have a matching 1. So I will move to the right side, and when I move to the right side, I will have number of zeros over there. I will just keep them and then move to the right, keep on moving to the right. When I see a 1, I mark it as y, and then I have to move to the left. I'll move to the left, and when I move to the left, I will read zeros. Again I will move to the left, I will read x. So when I read x, which means I have come at the extreme left end. So I have to again move to the right. So from here, from x, I will move to the right over here, and now I will read 0. So after I have read the 0, I will mark it as x. Now I have to move to the right. Right, I will have a y, just keep the y as it is, and then I will move to the right, and I will read a 1. When I read a 1, I have to mark it as y and then move to the left. So for each of the 0, I check whether there is a corresponding 1 to it. The 1 should be present after all the zeros. Okay, and then when I move to the left, now I have read the x here, and after x, when I try to move to the right, I don't read a 1. So I am reading a y here. Yes, because it will be y here. I am reading a y, I move to the right. So there are no more zeros to be read. So after x, In the previous step, what we have seen, after x, when I move to the right over here, I read the 0. So I gone through the right path and checked whether there is a 1. Now the second iteration, when I come, after this x, when I move to the right, there is no 0. There is only y, which means the 0 component of the input is over. And therefore, the 1 component should also be over. There should be no 1. So I have to keep on moving to the right. I should read a y. Again, I move to the right. I should read a y. Again, I move to the right. I should not be reading a 1. Yes, I should be reading a blank because it will be blank here. If there is a 1, it means 2 zeros and 3 1, which is incorrect. So therefore, for 2 zeros, you should have only 2 1. So all these are the steps you have to keep in mind before constructing the solution, before going deep into the solution of the problem. Okay. So therefore, now we have initially this entire tape symbol which is blank, and assuming the problem at hand, we have to be aware of the logic behind solving the problem, which is in this case it is any number of zeros followed by the same number of ones. Since the logic we are choosing is for every zeros that we read, we mark a x, and for every one we read, we mark a y. The tape symbols will be this 0, 1, x, y, and by default you'll have a blank symbol. Okay. Now in this slide, as you can see, I'm having the pointer, I'm having this tape head over here. Yes. So always assume that from the tape head, the symbol on the right will be scanned. So from the tape head here, 0 is going to be scanned. We have assumed the input to be 3 zeros followed by 3 ones, which is a valid input. We take this input and try to construct a Turing machine for that, and then we can prove that this Turing machine will accept the set of all languages, which is of type 0 power n, 1 power n, such that n is greater than or equal to 1. The initial state I am choosing is state P. So from state P, using the tape head, I am reading the input 0. So the transition will be like this: delta of P comma 0 is equal to. This is what we have to write. This Q comma X comma R. What is that is, whenever I read a 0, to mark it that I have read, I am going to replace the 0 by X. So therefore, the 0 is now replaced to X. After replacing to X, I have to move the tape head to the right direction. Why to the right direction? Because I have to pass on all these zeros and then I have to read a 1. So only if I move to the right, I will be able to go along and read the symbol 1. So therefore I have to move to the right. Now for this I have made a state transition. Whenever there is a symbol which is 0 and I am replacing it with x, I am doing a state transition. Yes. So therefore similarly I am placing it in the transition table also. P comma 0 is equal to Q comma X comma R. Yes. Now the simple 0 is changed to X and the state is also now Q. Now Q I am reading 0. And this state Q, I can have it for just reading zeros and doing nothing. Okay, so my transition will be Q comma 0 is equal to, I will be staying in the same state Q. I will not do anything to the input symbol 0. 0 will be same as 0. I will just keep on moving to the right. Yes. So from Q, I am reading a 0, just move to the right. Again, from Q, I will read a 0, move to the right. Okay. When will the state transition be? When I read 1 from state Q. So until that, this transition will remain as it is. Since it's a new transition, we can include it in the transition tables. Q comma 0 is equal to Q comma 0 comma R. Again the same transition. Q, from Q, I am reading a 0. It will be same as 0. I have to just move the tape head to the right side over here. The transition is already written, so we are not rewriting it. Again, Q, I am reading a 1 now. So which means from Q when I read a 1, it means that I have already read the 0 and marked it as X. And for that 0, now I am parallelly reading a 1 over here. So this 1 should be marked to Y and that should be a state transition. So whenever we write something to the tape symbol, we do a state transition in this case. So therefore, Q comma 1 is equal to, from Q I am moving to state R and this 1 is replaced by Y, and after replacing this 1 by Y, I have to again move to the left to scan the remaining zeros and then correspondingly check whether there is matching ones for that. Okay, therefore the direction of the tape head should be to the left side. So from here the pointer will move to this end after marking it as Y. So since this is a new transition for Q comma 1, you can add it in the transition table over here. Yes, so this 1 is now changed to Y and also the tape head which was here has moved to the left over here. Now we are in state R and on the way towards this extreme end I mean until you reach X, you will be reading zeros now. So all these zeros, you have to keep it as zeros, just have a direction movement to the left until you see a X. So therefore from R, when I read a 0, it should be same as 0, just move to the left. From R, when I read a 0, stay in R, 0 will be same as 0 and I have to move to the left. So this is a new transition, so you can add it in the transition table. Even the next is the same transition, R comma 0, I am having it as 0, move to the left. So I'll have the tape head over here in the next. Yes. So from R, when I read a X, it means that I have arrived the end. So therefore, I'm now going to the starting state itself to continue reading zeros and corresponding ones. So from R, when I read a X, the starting state is P. I'm going to P. I'm not going to make any change to this X. X will be same as X and just move into the right direction. As this is a new transition, we can include it in the transition table over here. So now from P I am reading a 0. This is the transition which we initially wrote at first. So the 0 is changed to X and I'll move to the right. And also the state transition is from state P to state Q. Okay. And from Q I am reading a 0. From Q, when I read a 0, I have to just move to the right. I will not make any changes to the tape symbol. Similarly, we are reading a Y now. We are not going to make any changes to this Y also. After reading a 0 and marking it as X here, we have to check for the 1. So intermediately, if there are any symbols, we have to keep it as it is. So what are the symbols possible intermediate? In the first case, it was only 0. Now you are reading a Y also. So this Y should also be as it is. So Q comma Y is equal to Q comma Y comma R. Since this is a new transition, you will include it in the transition table here. I just move to the right. Now from Q, I am reading a 1. From Q, when I read a 1, we have done this transition already. R comma Y comma L. So make this 1 as Y and move to the left. The state will be R. Now from R, when I read a Y, it should be same as the Y. We are not making any changes. The state is also the same R. So R comma Y is equal to R comma Y comma left. Until when we have to move to the left? Until you read a first X. So even if it is 0, 0 will be same as 0. Just move to the left. Now when I read a X, this X should be changed to, sorry, X will not be changed. Now I will just do a state transition. Yes, I'm going to the starting state. so that I can again from the beginning read 1 zeros and its equivalent 1. As you can see in this tape as of now, there are 2x and 2y, which means for the 2 zeros I read, there are 2 ones, which is correct so far. Now from R, I am reading X. I am just making a straight transition to P, and also the direction of movement is right R here. So here from this tape head, the tape head will be over here. So again the same process. From P, I am reading a 0, mark it as X to the right. From Q, I will read a Y, let it be Y itself, move to the right. Again from Q, I am reading a Y, let it be Y, move to the right. And now from Q, I am reading a 1. So therefore, this 1 should be changed to Y, and I have to move to the left. Yes, from R, I am reading a Y, move to the left. From R, I am reading a Y again, move to the left. And now from R, I am reading X. So therefore, I have to move to the starting state. So in this case, as you can see it physically over here, all the zeros and ones are complete. So for after this state transition, that is next state will be, since we have P comma X comma R, the tape head will be here. We'll have the state P over here. Usually from P you were reading a 0. Yes. Now after this step, after this transition has occurred, from P you will be reading a Y. You don't have a transition here for Y. P comma Y, there is no transition defined. This is the first time you are going to read a Y from the state P. What does it mean when you read a Y from the starting state? Which means all the inputs, all the zeros are complete. If you had a 0, you would have read a 0 only from the state P. I would have read only 0 so far. Yes. And now since all the zeros are complete, now from the state P, you will be reading a Y. Yes. So therefore, now that the zeros are complete, the 1 should also be complete. Okay. So the next transition will be, as we know, it is P comma Y. Yes. So now we have a transition to a new state S, and this Y will be same as Y, just move to the right. So I have included the transition here, and from the state P, I will be moving to S, denoting that all the zeros are complete. And from S, I will start reading all the Y's. Yes, when I go to the right, I should be reading only Y's. There should be no 1. If there are any 1, it means that there are more number of 1's than the number of zeros. So therefore, now the state has transited to S. So the next step will be, the state head will be over here and the state will be S. So from S I am reading a Y, I will stay in S itself. Again from S I am reading a Y, I will stay in S itself. Again, when I read a blank, then I can reach the final state. Yes, so this T, I can mark it as the final state, and I can move to any direction, either left or right. That doesn't matter. So here I have given as right. Okay, so if I don't read a blank, then if I read some other symbol like 1 or 0, then what does it mean? The input is not valid. So I should not reach the final state. I should reach some other state which is a dead state. Okay, so here I have placed like from S I am reading a blank, and then I am transiting to state T, and I assume that state T to be the final state. Okay, so therefore this is the case. And now the transition table is complete. What all transitions table cells which are not filled, I can just give a hyphen to it, and I can mark the starting state with an arrow mark and the ending state with the star or a circle over it, and we don't have any transition from the final state. Okay, so all this is a transition diagram, and this transition diagram can be replicated as a, sorry, this is a transition table. Transition table can be replicated as a transition diagram. So see the transition diagram, the enlarged transition diagram is given here, and here you will have a Turing machine with 5 states with one start state and one final state. And from P, there will be an arc to Q for the input symbol 0. 0 is replaced with X and the direction of movement is right. Yes. Likewise, I can construct the transition diagram like this with the help of the transition table. Hope you have understood how to construct a transition diagram or how to construct a Turing machine for a given problem at hand. We have to understand the logic behind it, and then you have to construct a transition table parallelly, and at the end you will convert the transition table to a transition diagram. Now let's see how you can check whether the given input is accepted by a Turing machine or not. So we have considered Turing machine for 0 power n, 1 power n, and yes, now we will check whether 0011 is accepted. To check whether the given string is accepted, we use the instantaneous description or ID of a Turing machine. The initial ID will be the state P followed by the input to be read. So the state P is the starting state, 0011 is the input we have to check. So after all the inputs are complete, we have to reach the final state, which is the state T. In that case, the input is accepted. If not, then input is not accepted. So the state P here means the input head, the tape head is over this input symbol 0. Okay. So I have made the transition table here for easy reference. This is the initial configuration. So P0011. So from P I am reading a 0. What does it mean? From P I am reading a 0. I will go to state Q. 0 will be changed to X and direction is right. So the next ID will be the 0 is changed to X. Yes. So this will be X. I am moving this P to, from P I move, state transition is to Q. So Q, X comma Q, and then a 0 and then 1 1. This will be the next ID. Okay. So XQ 011. XQ011. So what does it mean here? From Q I am reading a 0. So what if from Q I am reading a 0? It is Q comma 0 comma R. I will be in state Q only. 0 will be same as 0, but the direction is R. Therefore, the next ID will be X0 and then Q will be over here and then followed by 1 and 1. Okay. X0 Q11. X0 Q11. From Q now I am reading a, from Q I am reading a 1. So therefore, sorry, I have moved to the next one. So from Q I am reading a 1. So which means the state transition is R, 1 is changed to Y and direction is left. So therefore, here the direction to be moved is over this. So after this X, before this 0 I will have the state R. But this 1 is changed to Y. So I will have X R0 Y1. Okay. So the next transition will be from R I am reading a 0. So from R, if I read a 0, I will be in R. 0 will be same as 0, move to the left. So R will be moved to the left. So I will have R, this will be X and then a 0 and then Y and then a 1. So it will be RX0 Y1. Rx0 y1. Similarly, we read the remaining simples. So from R, I am reading. Yes. So from R, I am reading X. So from R, if I read X, I have to be in state P, x will be same as x and the right direction. Therefore, x P0 y1. So now it is x P0 y1. So from P now I am reading a 0. So 0 will be changed to x. I have to move to the right. So the next ID will be xx qy1. And again from Q I am reading a y. I have to move to the right. So xxy q1. From Q I am reading a 1. So 1 will be changed to y, but I have to move to the left. So also the state is r. So that will be xx ry y. Then from r I am reading a y. It will be again to the left till you reach a x. So therefore it is xrx yy. From R I am reading x. I have to move to state P and the right direction. So xx pyy. From P I am reading a y. So from P when I read a y, I have to move to new state S. Y will be same as y. Then the right direction. So xx y s y. From S if I read a y, again to the right. So xx yy s b. B for blank. And from S if I read a blank, then I can move to the final state. So the last ID will be xx yy btb. So that's all. And starting from the starting state P, I have read all the inputs in the input tape, and also I have reached the final state T. So therefore, the input 0011 is accepted. So the entire input is scanned and the Turing machine has reached the final state. Hence, the input 0011 is accepted by the constructed Turing machine. So this is how you can check whether the given input is accepted by the Turing machine or not using the ID of a Turing machine. Thank you.